Yeah, so this is a question from GATE 2022. The question is the steady state output Vout of the circuit shown below is. So here there is an op amp based circuit and it's an integrator. So we'll see how it works. So a 0.1 volt DC voltage is applied here, and considering this is an ideal op amp circuit, and at the non-inverting terminal through resistor R2 it is connected to ground, right? So this voltage is 0. So this is a virtual ground, so we can consider this as having 0 volt, right? So what is the current flowing? It will be, current will be flowing like this, and this current we can call it as I1. This is equal to the voltage drop across R1, that is 0.1 by the resistance R1, right? This current is again flowing into the capacitor C1 like this, and it will charge as plus minus. So V out, and if this is the voltage, what is this voltage? We will call the voltage across the capacitor VC1 as 1 by C1 integral 0 to T I1 dt. I1 is the current flowing through this, right? And this voltage is equal to minus V out, right? So with respect to this, it is just having negative polarity, right? V out is equal to minus VC1. So implies V out is actually equal to minus 1 by C1 integral 0 to T I1 is 0.1 by R1 dt, right? So minus 0.1 by R1 C1 dt. So integral dt. So when I integrate, this will be equal to into T, right? So V out is actually minus 0.1 T into R1C, which means the output, if I draw, so initially if V out is 0, this will be integrated like this, right? And as T increases, the V out will also increase in the negative polarity, okay? Which means at T equal to infinity, the output should go to minus infinity. But here the but there is always a limit, right? It will saturate to the minus saturation value, minus V set it should saturate. So what is a minus value? It will be minus VE. So definitely instead of going to infinity, it will automatically saturate to minus VE, right? So the correct output will be like this, right? So at a steady state, the value the output V out will become saturated to minus VE, right? So answer is B. Yeah, so this is a question from GATE 2022. The question is, for the circuit shown below with ideal diodes, the output will be. So the diodes are ideal and input signal is V in, which is sinusoid. Okay, so since this is an ideal diode, so during the positive cycle, okay, the polarity will be here plus, here minus. So if it is plus minus, diode D1 will be on, right? And since this is minus, D2 will be on. So it's like a short circuit. So this node voltage will be same at the V out, right? Or the voltage V in will be found across R1. So V out will be equal to V in for all V in greater than 0, right? And what happens for this case, that is when V in is negative, when V in is negative, here it will be minus, here it will be plus. So what happens, the diode will be open, okay, during the negative off cycle. So what happens, the circuit will be like this. V out. So what happens, V out will be equal to 0, right? So the answer is V out will be equal to V in for V in greater than 0. Yeah, so this is again a question from GATE 2022. The question is, in the circuit shown below, the switch S is closed at T equal to 0. The magnitude of steady state voltage in volts across 6 ohm resistance is. So I need to find what is the voltage across the 6 ohm resistance, right? So here initially switch was open and the switch is closed. Okay, so when switch is closed, definitely there will be a current flowing into this network and into this network. And at steady state, what happens, initially the current will flow like this, and at steady state the capacitor will charge and it will block the current flowing, this current, right, flowing into the capacitor. So the circuit I can draw as So this capacitor is open and it will be charged to some voltage. I'll call it as VC. Okay, and so this is 6, this is 3, and this is 10, and here this is 2 ohm. Okay, so this is 10 volt. So what happens? The current here is 0 ampere, so there won't be any current flow. So if it is 0, so this network is not there, right? Okay, so this network is not there. So I can draw the circuit as 263 10 volt. Okay, so the circuit is now like this. So what is the voltage across 6? Voltage across 6 is voltage across this resistance, right? That is 6 parallel 3. That is same as the voltage across 6. So what is it? I'll call it as V6, voltage across 6 ohm. That is equal to, it's like a potential divider, right? 2 ohm in series with 3 parallel 6. So I can write 10 into 6 parallel 3 by 2 plus 6 parallel 3, right? So 10 into what is 6 parallel 3? 6 parallel 3 is 6 into 3 by 9, right? So it is equal to 2 ohm. So I can write 10 into 2 by 2 plus 2. So that is equal to 5 volt. So answer is 5. So this is a question from GATE 2022. The question is the current gain I out by I in the circuit with an ideal current amplifier given below is. So I need to find what is I out by I in. Right. So here one op amp is given and this it's having infinite open loop gain and this is grounded. So definitely this is at virtual ground, right? And this current is 0. And I have in feedback one capacitor CF. So the impedance here is 1 by j omega CF, and output one capacitor is there. So its impedance is 1 by j omega CC, right? And there is one input current source here. So the current is flowing like this. So same current will flow through the capacitor like this, right? So this is the current. So since the current is flowing like this, the voltage drop across the CF is this one, plus minus, right? And that is same as the V out here. So I can write V out as the current I in into the resistance or impedance across the CF, right? That is 1 by j omega CF. That is this voltage. That is V out. Okay. And now, so this is equation 1. Now if you see here, carefully see, there is a current I out flowing like this, right? And because of that there is a voltage drop across CC, and that is again V out, right? So I can write here V out also as the I out into the impedance across CC, that is 1 by j omega CC, right? So V out is either I in into 1 by j omega CF, that or I out equal to 1 by j omega CC, and both are equal, right? Both are equal. So from equation 1 and 2 we can write I in by j omega CF is equal to I out equal by j omega CC. So I out by I in I can write as CC by CF. So answer is C.